So in last class we had discussed some of the basics of what the dynamics of horizontal circular motion. So today guys, we are going to see some more application of this concepts that we have learned about the dynamics of horizontal circular motion. So one of the things that we have to learn guys under the syllabus of JEE is designing of roads. Okay, so designing of roads is one of the things that we have to learn, not like proper designing but just the fundamentals, that how we like you can say like bank the roads, or what should be the radius of the turning roads that we should provide at a certain location. All those things we have to understand. So there are basically guys, there are three types of things that we have to understand. The first thing is designing of designing of designing of horizontal circular turns. Okay, horizontal circular turns, that is the first part. Then guys, there is the designing of, what we can say is designing of designing of roads, where we are going to give we are going to give banking. And here guys, we will ignore the effect of friction. Okay, ignore the effect of friction. This is guys what we can say our second part. Okay, or the second situations that we have to see. And then the third part is guys designing of roads, designing of roads where we are going to do banking, but take we will take the effect of friction. Effect of friction means friction would be what, significant in the calculation. Okay, so these are the guys, you can say, the three sub parts of this whole topic, designing of road, that we are going to see. So we will see guys today the understanding of how we do all these things, and maybe in the next lecture we will take some example on this. Okay, so let's today guys just cover the theory of these three things. And the theory is going to suffice actually the whole fundamentals, that how the things are actually happening. But for the sake of a little bit what more making the concepts more crystal, we will take some illustration in the next lecture. Okay, so guys, let's see the first case, that is the horizontal horizontal circular turns. So guys, let's try to understand this case. Okay, so guys, if you see, if we have a turn like this. Okay, let's say this is a 1 minute guys. Okay, this is a circular turn guys, we can say. And let's say this is the average radius that we are having of this turn. Okay, and you want that the car should go on this track, doing guys what, the motion. Okay, considering the body is what, moving like this. Okay, So guys, here if you see, this is the thing. Okay, so guys, we know that if the particle is moving on this circular turn, or this car is moving on this circular turn, it must have some centripetal force towards the center. Okay, so if at any instant, let's say guys, if the car is moving with a, you can say, with a uniform speed, means guys what, if speed is constant, 1 minute guys, if speed is constant, in that case guys, in that case what we can say, the friction force should act only in the direction of, in the direction of, in the in the inward direction towards center. Okay, towards center. So guys, this is the uh, very basic idea, that we know that if the particle has to go on a circular path guys, it should have what, a net force towards the center. And guys, this force has a certain limit friction available, which is there guys. It has a what, certain limit, we know that. So guys, the maximum friction that is available at the ground will be, we can very easily calculate guys, that F static that is available will be equal to what, is equal to mu s into m into g. So guys, when the we were looking for the maximum speed that you can take, with whom you can take this turn. Okay, the maximum speed, if you want to calculate guys, that what should be the maximum speed that we can have at this point of time to take this turn, guys, try to understand, there should be no component of the friction force should be in this direction, in the direction of what, velocity. Because if there is some part of the friction is used in this direction, then guys, of course, if this is the case, then friction in this direction will get what, available lesser. I hope you're getting my point guys. If you are increasing the speed during the turning, then in that case guys, what is going to happen, the friction will be needed in the forward direction also to help you to accelerate the car. Okay, and in that case guys, friction which is available for towards the center will get automatically what, reduced. So guys, if you are taking the turn and you want to calculate the maximum speed that you can have for the safe turning, you should be turning with the what, constant speed. Okay, that is the very important condition that you should understand. So guys, if we want to find out that what is the maximum speed that we can have during the turning, we can say that the friction force here should be equal to what guys, it is equal to what, mv square divided by r. Okay, the friction force should be guys what, towards the center, the total friction force should be towards the center. Then guys, this is the maximum speed that you can have during the turning on the horizontal circular road. I hope you're getting my point, the whole logic, that what is the primary condition for calculating the maximum velocity for a given road, that how much maximum speed, with how much maximum speed you can take the turn. Okay, so guys, with this idea I can say that if fs is equal to mu s into m into g, that is what guys, of course, if you are going for the maximum speed, the friction will be what guys, at its limiting stage. Okay, means the limiting friction would be acting at that moment. Okay, on the tires we can say, and guys, that will be equal to m v max whole square divided by r. So m guys, what, cancel. So v max will be equal to what guys, it will be equal to, if you see, it is mu s into g into r. Okay, mu s into g into r guys. Okay, so what we can say, that v max, maximum possible, is how much guys, is equal to, we can say, under root of mu s R into G. Okay, V max is equal to what, guys? Mu s into R into G. That is the maximum possible speed that you can have during the turning. Now guys, generally, like, this is just a extra thing that you can have in your mind, uh, that when, guys, generally as a civil engineers, when we design the roads, okay, we always take the factor of safety during the designing of roads. Especially in India, guys, we know that the people don't follow the rules in general. Okay, if we are saying that, let's say, the speed that is maximum limit here is 80, people will cross that, that's for sure. They are going to overspeed the limit. So guys, whenever we are designing the roads, we always take the factor of safety, and we overestimate the velocity, and we will put the sign. Let's say if we know that the maximum speed that can be there is 100, okay, so we will, what we will do, we will show the sign on the turning road maybe 70 or 80, okay, so that if they will overspeed, they will not go up to 100, they will go up to what, 85 or 90, and then they can take the safe turning. So guys, there is always an idea of what factor of safety is there in the designing of any, like, what we can say, any mechanical device, any like constructing infrastructure, if we are having, when we are designing the beams, columns, okay, footings, there also, guys, we take a lot of factor of safety. Okay, so if you pursue the civil engineering or mechanical, you will get this term factor of safety very usual, very commonly, okay, in every subject you are going to see that. So just wanted to put a little bit light on this term, okay, factor of safety. I hope you understood the logic behind it, why do we need that. Okay, so guys, from here we got the maximum possible speed that you can have during the turning on a horizontal road if the friction is what, guys, friction coefficient is what, mu s, and the radius of the road is r, and G is what, guys, gravity. Okay, I hope this is okay. Now guys, there is the second uh, type of category that we have to see, that is what, guys, banking of the roads. Okay, so case 2, guys, we can say case 2. Okay, here, guys, what we have to understand, we have to understand the banking of the roads. So guys, to understand this thing, that how the banking helps to take a turn on a circular road, I will introduce you a very common thing that you have done in your uh, like in your childhood also, and even now also, guys, maybe you will be doing this thing, that when you are taking a circular turn on the ground, and if you are riding a bicycle or something, guys, what you do, you generally, guys, you bend your cycle a little bit. Okay, you bend your cycle, and then you go. Okay, I hope you have realized this thing, that if you are sitting, guys, you try to uh, bend the cycle. Okay, you try to bend the cycle a little bit. It is not completely vertical, it will be a little bit, what, guys, horizontal, like inclined towards the center. Okay, so guys, actually what happens when you do this thing, you get an extra support in the form of what, the centripetal force for taking a safer turn. How, guys? Actually, like, this normal force that you are having, this normal force will have two components, guys. Now one component along this, 1 minute, guys. Okay, there is one component along this that you will have, let me choose some other colors. There is one component, guys, here, that you might have n cos theta, let's say, and this will be what, guys, let's say n sin theta. So this n sin theta will be there, but this n cos theta that you are getting, guys, it is going to help you to provide some extra sufficient force that might be needed during the taking the turn. Maybe friction is not like helping you much to take the turn, so when you bend your cycle, you get a extra help from this component of one normal force. Okay, I hope you understood why the banking is needed. Okay, so in the similar fashion, guys, if you see, if you have seen some races that gets performed on the in like in the foreign countries like F1 and all. Okay, there they, you know that they use a very high speeds of the vehicles for the whole journey. Okay, so there guys, generally what happens, the roads are not in general everywhere straight only, but there are a lot of places where when the turns are happening, there would be some sort of banking of the roads, means some sort of inclination of the roads you will see. Okay, so actually guys, if I show you, it will appear like this. Okay, if I just try to visualize you, so this kind of a thing guys, okay, this kind of a thing maybe you have seen. Okay, on the roads, that the little bit what banking is there. Okay, little bit what guys, this banking is there. Okay, there is some inclination you might see, and on this guys the vehicle goes. Okay, on this guys the vehicle goes and take the turns. So guys, when this banking happens, it is going to help you to provide a centripetal force with the help of what, the component of a normal force that is acting on you or on acting on the car by the road. Okay, so guys, let's see that and let's try to understand this thing. So guys, if you see, suppose I'll make a picture so that you can see what is happening actually here. So guys, this is a cross sectional view of a road. Okay, this is a cross sectional view of a road. I hope you're getting my point. Okay, so guys, here let's say the car is coming. Okay, the car is coming, so let me make a guys a simple car. Okay, and this is the tires guys. Okay, and this is the driving seat and this is the side seat guys. Okay, so if you see guys, this is the front view of the car. Okay, and this car is coming, and guys this is some angle theta. So guys, if this turn that you are taking place on a circular path. Okay, I hope you're getting my point. Are you able to visualize this thing? I hope you are able to visualize guys, that there is some center, and this is what guys, some radius that would be there. Okay, about which this car is going to take the turn. Okay, this car is going to take the turn. So guys, here if you see, the thing is that if you make the FBD of this body, so let's say guys, we are ignoring the friction, we are assuming that there is almost very less friction is available on this road and between the tires. Okay, so we are just focusing on the other forces, and can we do the turn with these other forces only. Okay, so guys, if you see here, there is one force, that is what, mg, that is acting downward, and guys there is normal force that is acting towards this. Okay, so guys, if you see here, the thing is, if this angle is what, theta. So guys, let me show you something. So here guys, if I make this angle will be all what guys, also theta. So now guys, just pay attention. Here if you see, if this is theta guys, this angle will be what, 90 minus theta, so this will be what guys, theta. So what we can say guys, this will be what, n cos theta, and this will be what guys, this will be n sin theta. I hope you're getting my point. So guys, if you look here closely, what you can see, that there is a component of the normal force you are getting towards the center. Okay, you are getting a component of a normal force towards the center, which is going to help you to take the turn on this road. So guys, suppose if you want to know that how much velocity you should possess here so that you can take the turn on this road, we will do the calculation. Okay, so guys, if you see here, the thing is, here if you see, the body should be in equilibrium. Okay, so if body is in equilibrium guys, in the vertical direction and only in the horizontal direction, it is moving on a circular path guys. So what we can say, that mg should be equal to what guys, n cos theta. This is what guys, the vertical equilibrium. You can see this should be balanced by what guys, this. Okay, so mg should be equal to what guys, n cos theta. That is the equation number 1. And second thing is guys, what, this n sin theta is the centripetal force that you are having towards the center, and this centripetal force should be equal to what guys, the like the velocity you that you are having, it should balance this n sin theta continuously. Then only guys, what, you can take this turn. So it means that the mv square by r that you are having, that should be equal to what guys, n sine theta. So guys, if you see, n is equal to what, n is equal to mg by cos theta, and if I put that thing here guys, what we will get, we will get that it is equal to mg tan theta is equal to mv square by r. So guys, cancel, so v is equal to what guys, under root of what, rg tan theta. V is equal to what guys, rg tan theta. That is the velocity that you should possess to take this turn guys. Now it is very interesting thing that you should know here guys, the c, if you see, if your velocity is less than what guys, rg tan theta, what will happen? If your velocity is less than rg tan theta guys, then in that case, if you see, the force that is needed towards the center, okay, to take this turn will be what guys, of course is needed less, but your force is what guys, n sine theta is more, okay, n sine theta is what guys, more. So what we can say, that this n sine theta is going to have, you can say, two components, one component along this, okay, and one component, if you see guys, this n sine theta, further I am just making the component guys, okay, so one component along this and one component along this, okay. So guys, this may be balanced with mg and all, okay, but guys, this component if you see, or like this way, if you try to understand guys, if this mg is this component, mg sine theta is also getting balanced by what guys, this normal force, okay. So mg sine theta and this normal forces are balancing each other in such a way that you can take this turn. But guys, if let's say your velocity is less than this rg tan theta, what will happen, you will, you will not be able to stay there on this track. Actually you will come down, okay, you will come down. Why? Because your velocity is less. So the n sine theta is more guys, of course. So what will happen, to maintain the n sine theta guys, you should need a lesser radius, okay, you need a lesser radius, then only you can do this thing, okay. I hope you're getting my point, okay. So because guys, if you see, if I'll show you here, if your velocity is less guys, okay, so of course if n sine theta is not going to change, it means what you have to change, you have to change the radius, you have to drop down the radius, then only what will happen, then only you can maintain this condition. Otherwise what will happen, you can't do the circular motion. So it means guys, if your velocity is less than this, what will happen, your car will slide down and you will lose that track of radius r, okay. So it means if your velocity is less than this rg tan theta, you are going to lose the track of radius r and you will come down, okay. And in the similar fashion guys, if your velocity is more than rg tan theta, what will happen, now n sine theta is not enough to handle this mv square by r value, okay. So guys, in that case, what if your velocity has been increased, so somebody should maintain this thing with this, then only you can take the turn, because n sine theta is not sufficient to take that turn in that case. So what will happen guys, you will automatically skid up and you will go in a larger radius, and then maybe you can take the turn, okay. So this is one interesting thing that you have to understand guys, that in this case, if you want to move on a certain radius circle, you should have a specific velocity. If let's say we are ignoring the friction, then guys, you should have a specific velocity, that is what, v is equal to rg tan theta. If you are maintaining this velocity of the car, then you can move on a specific radius of a circle, okay. But if guys, you change this velocity a little bit, either you will go down or you will go what, up. That is going to be the case in this case, if we are not having the friction, okay. So guys, of course this is not a practical thing to do, okay, it's not practical thing to do, almost it's very difficult, and this can't be a part of what, designing of a road, okay. So we should think something which should be what, more realistic. But guys, here just I want to show you the effect of what, banking. That's why we have taken this as a one of the case, okay. Now we will go to some more realistic situation where guys, friction is also what, take a significant role there, okay. So guys, let's take a next case, that is case 3. Case 3, case 3 guys, okay. And here we will understand guys, banking of roads, banking of roads by taking friction effect in significance, or just by taking friction effect into account. Okay guys, so this is the idea that we want to explore now. Okay, so guys, now again the same stuff we'll be having here. So if you see guys, that let's say this is your road cross sectional view, and guys let's say this is the road and there is a car that we are having. 1 minute guys. Okay, so let me make the car here. uh, okay guys, this is the front view guys only. Okay, front view of the car. I can just show a little bit. I think I have messed up. Okay, just give me a second guys, let me try this once again. uh, 1 minute. Okay, and then uh, leave it guys, leave it. Okay, let's say guys, this is the front view of the car. Okay, front view of the car. Okay, I hope you're getting my point. The thing is, it is conveying in a some different way, that's why I want to make it properly. How I made it there. Okay, let me make it like this way first. Okay, I think I am just, yes, now it's, I think, going in a certain way. Let me make this guys properly first. Okay, so guys, this is our car. It should look like a car guys, otherwise it's a problem. Okay, so this is guys what the car that it is now appearing. Okay, so I think guys, this is pretty much good. Now we can make a little bit backside designing also. Okay, okay guys, so now I'm a little bit satisfied with my art. Okay, so let's move to the concept thing guys. Okay, so let's see. The thing is guys, that this car might be moving on a some circular path. Okay, let's say guys, this is the circle. Okay, 1 minute. Yes, this is the circle on which it is going to move of radius r. Okay, now let's see guys, the forces that you might have here. Okay, so guys, see, the mg is acting downward. Okay, mg is acting downward, and guys, there is normal force is acting this way. The normal force have guys one component this side, that is what, n sine theta, and guys there is one force in this side, that is what, n cos theta. And guys, what we have seen, that if v is less than rg tan theta, and let's say guys no friction was there, so the velocity has sorry, the car has a tendency to go what guys, down. Okay, the car has a tendency to go down. So guys, it means if car has a tendency to go down guys, in that case friction will act what, up. Friction will act guys what, if it has a tendency to go down guys, maybe the friction will support you and you will not go down. So guys, there is a chance guys that this friction that is there, this friction guys, it might reduce what this centripetal force by its some component, and guys what will happen, you can go on this radius with a lower speed also. Why? Because friction is actually helping you to do that. Why and how, guys? If you see, guys, if you have a tendency to go down, in that case friction will act up, that is sure, I guess. Okay, and if friction is going to act up, guys, so friction will have two components, one component in this direction and one component in this direction. This component will reduce what, guys, this force. So automatically your centripetal force that is needed here will automatically reduce. So your mv square by r, which is less because you have less velocity, guys, is also less. So the n sin theta, the net effect of the net force towards the center will be also needed, guys, what, less only. So we can say that yes, we can move here also with the less velocity with the help of what, friction. Okay, so guys what I'll do, if you see, we will take the case of what, that let's say the friction is acting in the upward direction. If friction is acting, guys, towards the upward direction of the plane, in that case, if you see, if friction is acting like this, guys, okay, what will happen, we will be able to get a some lowest possible velocity to take the turn on this circular road. Okay, we can have this thing. So guys, let's do the calculation. So guys, if you see, if this angle is theta, so this will be also what, guys, theta. So this will be what, guys, f cos theta. And guys, we are talking about the limiting condition, so friction will be at its maximum value. So friction will be what, guys, it will be mu s into n cos theta. Okay, and guys, of course, this will be what, this will be your vertical component, and that will be mu s n sin theta. Okay, so guys, let's do the like making the body at equilibrium. So guys, if we do that, what we can say, we can say this, that mg should be equal to what, n cos theta plus mu. Okay, just I am replacing this mu s with the mu, guys. Okay, we will know that this is limiting condition. Okay, so mu n sin theta, that is the equation number 1, guys. And the second thing is that n sin theta minus, guys, f cos theta, that is the net force towards the center, guys. If you see, this is n cos theta and this is what, n sin theta, and this is what, guys, f cos theta. So this is the net force towards the center, and that should be equal to what, guys, your centripetal force condition. So means mv square by r, and this will be what, guys, your v minimum. I hope you're getting my point. Okay, so what we can say, guys, from here, if you see, I want v minimum, guys. So if you see, guys, here, let me calculate the n first. Okay, let me calculate the n first, and then I'll replace this here. So guys, mg is equal to n cos theta plus 1 minute, guys, let me do like this way. I'll take the n common here, and I'll get cos theta plus mu sin theta here. And then, guys, n will be equal to what, mg divide by mg divide by cos theta plus mu sin theta. So guys, if I use this n value here in the equation number 2, then what will happen, guys? If you see, the equation number 2 is what, n sin theta minus f cos theta. F is what, guys, nothing but friction force. So mu n cos theta is equal to m v r minimum. Okay, 1 minute, guys, just a minute. M v square minimum divide by r. So guys, here also we can take n outside, and we can write sin theta minus mu cos theta is equal to m v square minimum divided by r. So guys, here if I put n from this, guys, okay, if I replace this here, so what we will get, mg by cos theta plus mu sin theta. And guys, here what, sin theta minus mu cos theta is equal to m v square minimum divided by r. So guys, cancel, and we what got, guys, we get v minimum square is equal to rg sin theta minus mu cos theta divided by cos theta plus mu sin theta. So guys, this is the value of minimum velocity that is possible, and this guys we can write in a certain format, and that guys is advised that you if you can remember, please remember, because the derivation is a bit large. Okay, so it is advised that you should remember this thing guys, that is rg guys, and divide by the cos theta guys in the numerator and as well as in the denominator. So what we will get guys here, tan theta minus mu divide by uh, 1 plus mu tan theta. Okay, 1 plus mu tan theta. So guys, this is the minimum velocity that we can have in this case. Now if now if guys you have understood this idea, you can rewatch it guys. If you haven't understood any idea here, you can go again to rewatch it. Now guys, in the similar fashion we can talk about what, the maximum velocity case also. Okay, that what would be the case of maximum velocity. So guys, in that case if you see, I'll just redraw here so that I can explain with the clarity. So guys, if let's say this is our car, okay, this is our car, and this is the track guys that it is going to follow. Okay, this is the track that it is going to follow with the radius r. So guys, in this case if you see that this is what, this is your normal force, this is your mg, and guys this will be what, n sine theta, of course if this is theta. Okay, and guys this will be what, this will be n cos theta. I hope this is okay. And guys, if you are speeding up, okay, if you are speeding up, it means if your speed is getting more guys, the tendency of this body is to what, go up. And guys, if it is trying to go up, in that case friction will act what guys, down. Friction will act what guys, down. So guys, if you want to move on a circular turn on the same radius, you can move even with a very high speed also. Okay, with a good speed also. Okay, so what is the maximum speed that you can have during taking the turn on the same radius with the help of what, friction. So guys, here what will happen, if you see, in that case what will happen, the friction will, because you have a tendency to go up guys, friction will act what, downward. Okay, friction will act downward. So guys, friction will have two component now, that is what, if this is theta guys, this will be also what, theta. So this will be what guys, f cos theta. Okay, this is what guys, f cos theta, and this will be what guys, f sine theta. I hope you getting my point. So with this guys, okay, with this if I show you guys, this is what, this is your f, and guys this is theta. So this will be what, theta. So guys, this will be what, f cos theta, and this will be what, f sin theta. I hope you understood this idea of the components of forces. So now guys, I'll back to what, to explain this case of v maximum calculation. So guys, what we can write here, that we can write guys that n cos theta will be equal to what guys, mg plus f sin theta. And because guys we are talking about the limiting condition, of course friction will be at its maximum value. So it will be what guys, mu n sin theta. So guys, from here we can get the normal force value. So normal force will be what guys, cos theta minus mu sin theta is equal to mg. So guys, n will be what, mg divided by cos theta minus mu sin theta. That is the first thing guys, which is an important equation. And the second equation guys, we can write for the centripetal condition, that the net force that we are having towards the center, it should balance by the mv square by r. Okay, that's centripetal condition that we have talked about in the last lecture guys. So the centripetal force that we are having guys towards the center is n sin theta plus f cos theta, and that should be equal to what guys, m v max whole square divided by what guys, r. Okay, so guys, here if I put n sin theta plus, this is what guys, friction can be replaced with the what, mu n, because we are talking about the limiting condition. So v max divided by what guys, r. So if we take common n guys, here what we will get, sin theta plus mu cos theta is equal to m V max whole square divided by R. Now guys, we can replace the n, that will be what, mg divided by, guys, how much, cos theta minus mu sin theta. So cos theta minus mu sin theta into what guys, sin theta plus mu cos theta is equal to mv max whole square divided by R guys. Will be cancelled. So guys, what we got here, that V max square is equal to Rg sin theta plus mu cos theta divided by cos theta minus mu sin theta. So guys, V max that you can have is under root of Rg sin theta plus mu cos theta divided by cos theta minus mu sin theta. And guys, here also we can do this mathematical manipulation, dividing the cos theta in the numerator and denominator. We can have the formula guys, or the relation that we want is what guys, is, just a minute, okay guys, that will be Rg tan theta plus mu divided by 1 minus mu tan theta. So guys, if you see, this is your maximum velocity. So guys, if you want to take a turn on a banked road where the friction is significantly available, okay, in that case guys, you will not have a single specific speed or take the turn on the road. Even rather, you will have a guys, what, a range of velocity with which you can easily take a turn on the road guys, which is more practical and more what, suited for the designing of a road. Okay, so guys, what you can have the velocity now, that v can be less than v max or equal to that, or should be greater than or equal to what guys, v min. And that velocities are what guys, if you see, that is what, Rg tan theta minus mu. If you see guys, the values that we have derived, that is how much, if you see guys, tan theta minus mu upon 1 plus mu tan theta to what guys, to under root of Rg tan theta plus mu upon 1 minus mu tan theta. So guys, this is the range of speed that you could have when you are moving on a same radius circle on a banked road guys. Okay, so you will have a range of speed now. So this is the what, the most like suited thing that you can have during the designing of a road, instead of giving a specific speed to take a turn, which is almost impractical to do in the real condition. We have guys, what, a range of speed during the designing of this. Okay, so guys, this is called what, the designing, we can say. Okay, so guys, we have discussed all the three types of designing of what, the roads. Now in the next lecture we will see some examples on this, that how we can use these concepts. Okay, so I hope you guys, you have understood this lecture properly. If you have any doubt, you can let me know in the comments. Thank you.